Good morning, students. Thank you for joining my class today, chemistry class. Now, for today, we have two topics that we are going to learn. The first one is atomic structure, and the second one is bonding. Okay, let's start the lesson then. Now, uh, the atomic model that we usually use to explain about the arrangement of electron in atom, it is usually a quantum mechanical model created by Bohr. Now, in the quantum mechanical model, usually electrons they exist in different energy level. Yeah, they exist in different energy level. Now, so energy level usually identified as shell K, shell L, shell M, or shell 1, shell 2, shell 3. Now, there will be different maximum number of electron in every shell. To calculate the maximum number of electron in every shell, we will use the formula of 2n squared. So, the arrangement of electron in shell, it is what we call with electron configuration. Now, take a look at this electron configuration of sodium atom. To get the electron number of sodium atom, we get it from the atomic number. If the atomic number of sodium atom is 11, it means that the electron number is usually 11. Now, take a look at the first shell. The maximum number of electron in the first shell is 2. The maximum number of electron in the second shell is 8. The maximum number of electron in the third shell it is 18. But we just have one here because the remaining electron that we can put in the third shell is 1. Now, electron in the outer shell, that's what we call with valence electron. Valence electron is very important because valence electron is usually used to determine the chemical properties of an atom such as reactivity. Now, take a look at the periodic table that consists of many elements. In the periodic table, elements horizontally at the same row, that's what we call with period. So this is period 1, period 2, period 3. Period corresponds to the number of shells. If period 2, for example, it means that it has 2 shells. Now, then, elements particularly at the same column, that's what we call with group. Now, so this is group 1, group 2. And then element at the right side, yeah, it is started from group 13, 14, 15 to 18. Now, 10 column in the middle, yeah, it is what we call with transition metal. Now, let's discuss about chemical bonding. Now, to discuss about chemical bonding, we need to take a look at some physical properties of the atom. They are conductivity, electrical conductivity, and melting point. Now, solid, according to melting point, they are divided into two. The first one with a high melting point, the second one with the low melting point. Now, solid with a high melting point, usually it is not a covalent molecular substance, but solid with a low or non-conductor of non-low with low melting point, it is usually covalent molecular substance. Now, covalent molecular substance also cannot conduct electricity, whether it is in solid, liquid, or molten state. Now let's take a look at some solids that have a high melting point. If the solid that has a high melting point can conduct electricity, it is metallic substance. But if a solid it cannot conduct electricity, it will be ionic substance, and also the one that cannot conduct electricity in a molten state, it is covalent network substance. Now, let's take a look at the properties of metal substance. Now, the properties of metal substance, they are a good conductor of electricity, whether they are in a solid or liquid state. They are hard and also have high melting point and boiling point. Now, we are going to discuss how this metal has this kind of physical properties. Take a look at this diagram. Now, in this diagram, yeah, the valence electron of metal atom, this and this, the valence electron of metal atom, they move freely in a three-dimensional arrangement around the positive charged metal ion. So, it means that this positive, yeah, so it means that this positive ion is surrounded by electron. Now, this positive ion is attracted with mobile electron by using electrostatic force, which is called to form metallic bonding. Then, metals, yeah, they have a good conductor of electricity because of this free mobile ion. They carry electric charge through the metal. This is how the process of metal conduct electricity. Electron carry charge from one part of metal rod to another part of metal rod. Now, then take a look at why metal atoms, they are malleable. Now, take a look at this. Layers of positive ion can slip over one another without disrupting the metallic bonding. That's why it is called that metallic bonding is non-directional and it makes metal malleable. Next, let's take a look at ionic substance. Ionic substance is positive ion, the example here is magnesium metal, and negative ion arranged in a regular lattice. Now, it means that there is uh, there is a strong electrostatic attraction between positive ion and also with negative ion. Now, it makes this substance are very hard to cut since the electrostatic force between positive ion and negative ions are very strong. Now, ionic substance is brittle. Why ionic substance is brittle? Because when we apply force for one layer of ionic crystal, it will disturb the orderly arrangement of ion. Take a look here. When we disturb the orderly arrangement of ion, negative ion and negative ion will meet. Now, when they meet, of course, they will repel so that the ionic bonding in the ionic substance will be broken and the ionic compound will shatter. Now, let's discuss about the solubility of ionic compound. When a soluble ionic compound is added to the water, the ions will be broken. Take a look at this. The ions will be break away from the ionic lattice and there will be free ion. There will be free ion that move in water and mix with water. Now, but it's different if we have ionic compound which is in solid state. Ionic compound in solid state they cannot even move. So the ionic compound in solid state, since they cannot move, they cannot carry any electrical charge. But it's different with in molten or aqueous solution. In molten and aqueous solution, ionic compound will be broken to be positive and negative ion. That positive and negative ion will be free to carry electrical charge. That's why ionic compound is a good electrical conductor in a molten state and also in aqueous solution. Now, let's take a look at a covalent bonding model. In 1916, American chemist Gilbert Lewis suggested that the atoms in a molecule they share electrons. They share electrons. Now, the form of bonding between atoms that sharing electron, that's what we call it covalent bonding. Take a look at the example here. This is the covalent bonding model in hydrogen atom. Hydrogen has one electron and another hydrogen they has one electron. Now, one hydrogen bond atom bonding together with another hydrogen atom by sharing their electron. So look at here to form covalent bonding. Now, then covalent substance, yeah, they have low melting and boiling point. For example, here water. Water has covalent bonding. When we heat water, so heat energy will break the bonding between one water molecule with another water molecule. Now, the bonding between one water molecule with another water molecule is covalent bonding, and the bonding is quite weak. So, energy needed to break the bonding between one molecule with another molecule will be very low. That's why a covalent substance, they have a low melting point and also low boiling point. Now, next, the last substance that we discussed today is covalent network substance. Covalent network substance is different with covalent molecular substance. Yeah, if covalent molecular substance, they are brittle and also soft, but covalent network substance, they are very hard and also brittle, and they are chemically inert and insoluble in most of the solvents, for example water, but it's different with covalent molecular substance because of the covalent network substance, they have very high melting point and boiling point. Why the covalent network substance has very high melting point and boiling point? It's because of the bonding between one carbon with another carbon, yeah, between one carbon and another carbon, will form a three-dimensional network, so the bonding will be very strong. Usually, covalent network substance exists between the bonding of carbon atom, yeah, between carbon atom and also silicon atom. Okay, that's it for the lesson today. I hope that you can understand the lesson. But if there are some questions that you need to ask me, you may ask me through WhatsApp. Um, then through WhatsApp, I will wait for that. And then beside that one, you also need to do the exercise that I gave through Edmodo. Thank you for your attention. Goodbye.